Welcome to the 16th video in this video series of using Godot with the Writer IDE to create and modify a 3D mesh. In the last video, I went through how using the tri-mesh collision and the concave collision shape, how that was a much, I would think, a better solution for determining which face has been selected than the one that we implemented in code for 3 or so videos ago. This is hopefully going to be the final video in this video series, where the point of this video series has been to create and modify a 3D mesh. Well, we created the mesh by creating the cube, but now we need to modify the mesh. And I think what I'm going to do here, in fact I know I'm going to do this, is I'm going to subdivide a mesh. So what we're going to do is we're going to select a triangle of the cube. It's going to turn purple, and then we're going to hit a key, the S key, to subdivide, and then it's going to subdivide that triangle into other triangles. So before we get going there, let's reset things back to a somewhat sane state here when it came to the moving stuff around to test our new way of doing the collision checking. Okay, so this video is probably going to be one of my longer ones. I have been trying to make, I started out the series with like an hour video, and then I had some longer ones at the beginning, and I've been trying to do between 15 minutes and a half hour. This one's probably going to be one of the longer videos, but we'll see how quickly things go. But for the grand finale of the video series, maybe that's not such a bad thing, because I'm sure many of you have figured out that I tend to talk with a slow cadence, and I tend to, I guess, talk through things. I don't like leaving things unmentioned. So you probably know this already, but on YouTube there is a speed that you can select to listen to, and if the 1.0 is a bit slow for you, you might want to knock it up to 1.5, 1.25, whatever makes it sound like I'm actually not just talking the slow way that I do. Okay, so let me restate again what I'm looking to do. So let's start the game here. So what I'm looking to do here is when we select a triangle on the cube, like this triangle here, I'm going to want to hit the S key, S as in Sam, or S as in subdivide in this case, and then it's going to split this into 4 other triangles. Well, the first thing we need to do is we need the ability to, once we have something selected, to not select it. So we have to implement that feature first. So let's, like I have been doing the whole series, let's start out simple and then we'll get to the harder and harder stuff. So the first thing we need to do is, let's go to Writer, is we need to, this shape index that we're getting in from this parameter for the callback for the static body, we want to store that somewhere, like we were doing with the Alt key or the Control key being pressed. We want to store that somewhere that we can get to it elsewhere in the code, because the way we're going to know if something's selected is if this variable is set to something, and then of course we want to be able to pull out what that thing is. So I think what I'm going to do is at the very top here we have these member variables. I think I'm just going to make another one, and initially I'm just going to call it this. However, I'm not all that familiar with C#, so my knowledge as I have been working on this video series, I've been learning C# as well as Godot. So one of the things I found out was C# has this ability to create nullable values. So like if I just try to do this to set this value to null, this integer, this primitive type, it's not going to allow that to happen. However, C# has this thing where if you put a question mark after the end of the data type, you can now set that as a nullable data type. And just because I had to look this up, so if you look up some references on C# for this nullable type, this essentially allows you to set something to a null if you want to for a primitive data type. Well, I'm going to be doing it for a primitive data type. So the reason I'm doing that is, I technically could if I wanted to. What I could do is instead of having when it's not selected be null, I could have it be like -1. But I'm just going to have it be so it's null so that I'm learning something new. So, we'll go along with that. So then the next thing we need to do is we need to, let's go down here. We need to store the shape index somewhere when you click on it. Because right now, this shape index here, this is only coming in as a parameter for this method. It'll be gone once you're out of this method. So let's just do this. Let's just do a this dot shape index equals shape index. And then the draw selected outline, that's fine to use either one of those. So now it's being set to shape index. The member variable shape index is being set to the parameter value shape index. So the next thing we want to do here is, so we want the ability to unselect. So we need to go up to our method that's drawing the outline. That's the method that we're using to make the shape. If I can find it. Don't make me bring the outliner up. Draw face normals. Draw axes. Draw wireframe. Draw selected outline. Okay. So we want to make sure that there is the ability to pull this out, this immediate geometry like we're doing here. If one exists already, if one doesn't exist, we'll create it. Otherwise, we'll use the one that's there. We already have that. So we just need to accommodate the -1. So what we will, I think, do here is, what we will do is, actually, I'm not sure we have to do anything here. No, because this thing here is going to be messed up. So what we want to do is after what will happen is if we let the -1 come in as, if we want to unset this, we have to pick a value that we want to be unset. And so what I'm going to do is I'm going to say, I guess I could make this a nullable like I did above, but I'm just going to have this one be, hey, if I select the face of -1, don't select anything. So what we want to do here, because if we set -1 here and then we try to access the starting vertex based on the math we're doing here, this is all going to be messed up. So basically we want to do a check here. We want to, after the clear, we want to say if the what's that parameter called? Selected face. If the selected face equals -1, then we basically just want to exit out of this method. So what this means is if we send in, let's scoot up here. If we send in the selected face of -1, what's going to happen is it's going to clear the immediate geometry that we were using for the selected face. And then if it's -1, we're just going to return, so it's not going to draw anything, so that'll unselect. So we wanted the ability now to test this. So what we should do is go to our input method, and let's have it so if we right-click on the cube, it unselects the face that we had selected. So what we want to do here is actually we want to go down here to the static body input event. So we have this. When we left-click is where we're doing the check to see if it's intersected with anything. So what we want to do here, and let's steal this. So we want to have, when we're clicking on the cube, we want to say if the right mouse button is clicked on. And if it is clicked on, then what we want to do is we want to set the this.shapeIndex to null. And we want to draw the selected outline. We want to set that to -1. And now that I'm thinking about this, we might actually want to make that a nullable too. But let's just see if this works, and I might actually change that selected face to a nullable too. Let's see what happens here. So in theory, if we got this right, we're going to click on this triangle and it's going to select it. Now if I right-click, it unselects it. So that's what I wanted. So I'm just wondering, let's make that nullable. So I can just send in the shape index directly like that. So we're basically calling the shape index with the null value. So if we do that, then we have to we have to go to the draw selected outline, and we need to make this a nullable value. And if we make that a nullable value, we're not checking for -1, we're checking for null here. And because it's a nullable value, we can't store this. We can't use this to store the result in an integer by itself that's not nullable. But since we already checked if it's null up here and it's going to bail out, what we can do is say, give me the value of the selected face, and then use that as your starting vertex. So that's just one of the properties of using nullable. If you're doing something with that value that's going to give you back something, it's still going to have that nullable quality. I mean, if we didn't do this value, we would have to do this, and then of course that'll fix that, but then down here it's not going to work here. So it's just easier to do it this way. So that should take care of that. Let's fire the game up and make sure that that actually fixes what I think. Looks like Godot closed up on me for some reason. All right. Not sure why that was. All right, so let's hit the play button. All right, we'll click here. Now if I hit the right mouse button, that doesn't work. Let's look in the code here again. Hit the right mouse button, clicked. Shape in, oh, duh. Probably my fault for calling it the same thing, so let's see if this makes it any better. Click. Yeah, so now I can click anywhere in the cube to make it to go away. So we have the ability to unselect anything. Now, that the right click that we implemented isn't necessary for the subdivide. I just did that so that we would have a way to test to make sure this is working, and it is. At least the right click is. All right, so now we have to start thinking about subdividing our mesh. And this is where it gets a little bit, I guess we'll say interesting. First, let's just put in our input method, let's just put a placeholder for the S key for subdivide. So let's copy one of these. And instead of escape, we want the letter S. And instead of get tree quit, let's just call a method called subdivide. Well, we don't have a method called subdivide. Well, let's make one. So we'll go to the bottom here, and we will create a private void subdivide. And for right now, we'll just have it print subdividing some exclamation points. All right, so let's go back to Godot. Let's fire up the game. Let's click on this. Let's hit the S key. And you'll see down there it says subdividing. So at least we're accounting for the subdividing functionality. Now, before we allow subdividing to happen, we want to change one little thing, because it's not sufficient for just to be pressed. The S key, let's go back up here. It's not sufficient for the S key to just be pressed because, well, we want to make sure a face is selected. So we also want to make sure that this .shape index is not equal to null, because if it's not equal to null, then we clearly have a face selected. So we need to make sure that the S key is pressed and that the shape index is not null, which means a face has been highlighted already. And then so after we subdivide it, we are going to want to after the subdivide, or maybe in the subdivide, we'll have to decide how we want to do it. Then we want to make sure we unselect everything. But let's not worry about that now. Let's just handle the subdivide. So then the next question is, let's go down to subdivide here. Well, how are we going to subdivide? Well, the first thing is we're going to need to grab the cube and the cube mesh stuff and the vertices. So basically, let's steal this from here, these first 3 lines, and let's come down here and let's add those. Add those here. There we go. So we've done this before. We're grabbing the cube mesh instance, we're grabbing the mesh, and we're getting the vertices because we're going to need the vertices in order to do anything with the mesh. So the next thing we want to think about doing, let's no, we'll keep it like that. So the next thing we want to think about doing here is like, well, what does it mean to subdivide or to subdivide a triangle? Well, I want to show you a diagram that I have, and then we'll pop back and forth. So what we're going to want to do here is, so let's say we have a triangle here, and the points we have are A, B, and C. Well, how are we going to subdivide this triangle? We have one triangle here. Well, the easiest thing to do is to basically take a halfway point on each one of these lines, the edges that are connecting the points. So what we would do here is we would do something like this. So we would find the halfway point on each one of these lines, these edges. So I just called them just so we can kind of have an idea of what's going on. This point's A, this point's B. Well, this point now is AB. This point's B, this point's C, this is BC, this halfway point. And this point C, this point A, this point is CA. So then how do we make a triangle out of this thing? Well, the way we would make a triangle out of this thing is what we would do is we would basically, we would add some extra edges here. So we are no longer going to have this ABC triangle. Where there was an ABC triangle, there's now 4 triangles. And, you might look at this and go, well, I only see one triangle, dude, that green one. Well, no, there's 4. So A, B, C, A, this is one triangle. A, B, 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 C, this is the second triangle. Then down here you have B, C, C, and C, A, this is another triangle. And then finally you have this one that you probably saw from the get-go, this A, B, B, C, C, A. So we've got one triangle here, one triangle here, one triangle here, one triangle here. So that's how we're going to subdivide. We're going to replace the A, B, and C triangle that's in the mesh with these 4 triangles. So then the question is, well, how are we going to do that? Well, what we want to do here is we want to, let's go back into Writer. Now, we probably don't need to do this because we're already checking if the shape index is not null, but I'm just going to put an extra safety check in here just for the heck of it to make sure it's not null. It should never be, but in case this code is ever later on called from outside of this method, outside of the callback method, that we can account for this, that it's not going to blow up. All right, so then the next thing we have to figure out here is, how are we going to replace the triangle that's already in there with something else? And basically what we're going to do is we're going to use the SurfaceTool, and we're going to rebuild up our mesh and replace that piece of what we need. Now, if we were just moving pieces around the current vertices, we wouldn't have to recreate the mesh. We could just move those points themselves using the mesh data tool. Mesh data tool just using the mesh. But because we're actually creating geometry And if you remember, these vertices are stored as an array mesh. So they're packed together. And as far as I can tell, because it's an array mesh, you can't move them. They're contiguous, that you can't move them. So you're going to have to rebuild a new structure. So what we're going to do here, we're going to build this in pieces here. So how about for right now, what we do is we just rebuild the mesh structure as it is now without building any new geometry. Just kind of getting things going. We're basically going to build itself. So we're going to use a list of vector 3s. Since we don't know, we do know if we did the math here, we're going to be adding those 4 triangles. But let's just use a list that let's just use a list. That way the new data item can grow as much as we need. We don't have to define an array with its ultimate length ahead of time. So what we want to do here is let's just call this list of vector 3s. Let's just call these new vertices. And what this will equal is a new list of vector 3s. So I don't know how many people have seen a list versus an array. So an array, you have to have a constant size. We have this, normally what you would do is you would do something like equals blah, blah, blah. And you would do that. You would define its size, and that's as big as it is, and that's it. Well, we get away with that up here. There's a shortcut that you can say is on your initialization, you can say, well, I know it's a vector 3 array. Whatever's on the right side of the equal sign here, get that thing back and store it into this new array. And so this new array kind of dynamically, only at initialization time, let's say this is also 12, it's basically going to do something like that. Well, once it's initialized, as far as I know, you cannot change an array in C#. In fact, in other languages, you're not supposed to because you're guaranteeing contiguous memory, and you don't know what's in the other memory outside of what you've defined. So when you define a list, what you're basically doing is saying a list data structure is kind of like an array, except the thing it doesn't have a set size. Internally it does, and it's doing some magic behind the scenes. But basically, you can just keep adding to this list. You can keep adding and adding and adding and adding, and it never hits the array limit of what you've defined the max array size to be. So that's why we're going to use a list here. So what we want to do basically is we just want to, for right now, we just want to copy the data structure that we had now. So in order for us to do that, we're going to need, well, first we have to store each vertice into this new list. So what we're going to do is we're going to do a for each here. And what we're going to do is we're going to have a vector 3, and it's going to be a vertex. And in what collection? It's going to be in this vertices. Because this vertices is this variable here. This is all the vertices that's currently making up our mesh. So for each one of those things, what we're going to do is we're going to want to add to that list. We're going to want to add that vertex into that list. So hopefully we've covered for eaches before. We're basically going to go through each vertex in this vertices variable, which is the vertices that are inside of our cube mesh, and we're just going to add it to this new data structure. And you're going to be, initially it's like, well, why, dude? You already got that structure. Well, we're going to use the SurfaceTool to create basically a duplicate of this thing, and then we will start modifying it. But it's like, well, let's make sure it just works making itself so that we know at least we have that working correctly. So what we want to do is we've covered this a while back because we want a SurfaceTool, and we're going to create a new one. We covered the SurfaceTool in the video where we created the cube geometry ourselves. So if you need a refresher on that, go back to that video. So after we instantiate a new SurfaceTool, what we want to do here is we want to set it in we want to invoke the begin mode and set it in what mode we're drawing. And if you remember, we're going to be drawing in triangles, so we will set it to triangles. So the surface tool is all set to go. So now what we want to do here is we want to iterate through all of the new vertices and add them to the surface tool. So basically we're going to do another for each loop here. So it's going to be vector 3. It's going to be a vertex again, because we can reuse this variable name inside of this for each loop, because the scope of this variable only lasts within this loop. So we can use it again down here, because this variable scope never lasts beyond this last curly brace. But instead of vertices, well, no, now we're not doing vertices anymore. We're doing new vertices, because that's the new vertices that we created. I mean, by created, we just stupidly just added them back, but eventually we'll be modifying and needing to put them back. So what we want to do here is we want to do surface tool, and what we want to do here is we want to add the vertex. And what are we adding? We're adding the vertex. All right. And then after, let's scoot down here. After we're done here, if you remember from the cube generation video, when you're done with the surface tool, you want to have it generate the normals for you. So if you just do that, it'll compute all the normals for you. Okay, so then after that, well, now we want to assign this, the cube instance, we want to assign this, whatever the surface tool has made, we want to assign it to the cube mesh instances mesh. So basically, you see how you have a get mesh here? We want to be able to put this new mesh back in there. And we did this with the cube a while back, but I'm just kind of it's been a while since we did that video. So what we want to do here is we want to do a cube mesh instance dot mesh equals surface tool. And if you remember, the way to get the mesh out of the surface tool is you do a commit on it. And as you see here, it returns back an array mesh. Now, just so we know that this has actually done something, because in theory it's going to look the same. So we've got this, let's copy here, subdividing. We'll go through all this stuff, and then when it's done, we'll say done subdividing. That way we know it actually did something. So now we're going to run the game. Now, nothing should look different if we did this correctly. In fact, let's do this. If we don't do this generate normals, you'll see that the cubes, what should happen is the cube won't be that green color. It'll be like black, and but at least we'll know it did something. So let's temporarily comment that out, and let's run the game. And when the game comes up, we will select a triangle, and then we will tap the S key. So we will select this triangle, and we will tap the S key. Now, the cube still looks the same, right? I mean, it's still a cube shape. But the color is all black, which is what I predicted, because that generate normals. If you didn't generate the normals, the lighting, it doesn't know how to handle the lighting. So if we go back to a writer and we uncomment the generate normals, and now we run the game, other than the text down here, the cube should look exactly the same. It should be that green, and everything's good. So we'll select this, and we'll tap the S, and it says subdividing, done subdividing, but you couldn't really tell visually that the cube, anything happened to it. So that's good. That means we were able to use the surface tool to recreate the cube, and woo, I mean, it sounds like that's not a big deal, but it actually is, because now that we're going to start, the next step here is to then subdivide that triangle based on that algorithm that we talked about taking halves of the currently selected triangle. So like the halves here would be like this would be that AB, and then this would be that BC, and then this would be that CA line, and then we would generate the geometry inside there. So let's go back to our code. So the one thing that we haven't done yet is, so like after it's done, you notice that it's still the triangle still selected, the selected face. So what we probably want to do is kind of like what we were doing with that right mouse button. We want to call draw selected outline. Actually, we probably want to set the shape index to null. And then we want to draw the outline. And we want to send in the shape index. So what that should do is that should basically unselect the shape index. And then we already set this draw selected outline, so if it gets a null coming in, it unselects things. So let's go back here, hit the play button, and then we'll select the triangle. Select the top one this time. Now if I hit S, it unselected it, and the geometry's still there, so we're still good. So everything is as we left it, so that's fantastic. All right, so let's go back to our diagram here. So let's go back to this one. So now we have to start slice and dicing. We need to find the triangle in the mesh that is the selected triangle, and then we have to start slicing it up like we're doing here. And then after we slice it up, we want to reconstitute it with the rest of what's inside that mesh. So what we want to do, let's go back to Writer. What we're doing currently is we're going through all of the vertices, and we're just recreating the SurfaceTool as it is now. And that's fine for what we're doing, but now we want to start getting a little bit more specific. So how do we know where the how do we know in the vertex in this big line of vertices, how do we know like where our face that triangle, the triangle that we want to actually subdivide, how do we know where that is? Well, we know that by vertices. The way they're stored in a mesh is every 3 vertices is a triangle. That's just how it comes out. So what you can do here is what we can say is let's just say starting vertex index. What we can say there is we can say, well, that's going to be the shape index. Obviously, we have to use that value because, again, that's that nullable thing. Well, it's every 3, right? So our starting vertex index would be the shape index times 3. That will get us in this big, long array of vertices where our starting triangle is that we're going to want to slice and dice. Okay, so now we have to think about this. So what we basically want to do here is in this SurfaceTool that we've created this list of new vertices that right now we're just adding everything to. Well, we don't want to do that anymore, because the way we want to handle this, we want to say, okay, I want the mesh up until the triangle that I'm messing with, I want that to not change. I'm going to mess with the triangle, and then after the triangle, the rest of the mesh, I want it as is as well. So we want to basically copy the before in, then do our little messing with, our subdividing, and then after that, copy the rest of the vertices mesh as is into this new SurfaceTool. It'll be in this new list, which eventually will go in the SurfaceTool. So hopefully that makes sense. Basically, we want to copy the mesh before our triangle that's selected. Then we want to make our new triangle geometry and put that in there. And then after we're done, we want to take what was left in the mesh after our triangle and put it in there as is. So, the first thing is, well, how do we do that? Well, let's comment this out for now. And now we want a different kind of for loop because we don't want to copy everything. We just want to copy it within a range. So what we're going to want here is we're going to want a different type of for loop. So we're going to want our old buddy, the old for loop, where you initialize a starting an initialization. Let's put an I in there. Then you want to give it the test condition. Now in our case, what we're going to want to do is, while I is less than the starting vertex index, we're going to want to copy in here, and then we'll just do an I++. So we're going to do the same thing we were doing up there, a new vertices dot add, except this time it's going to be vertices I. So let's put a comment in here. This is going to be copy mesh data as is before selected face. All right, so hopefully this makes sense what we're doing here. So what we're going to do here is we're going to copy, instead of doing a for each, because we need to stop copying once we reach a certain criteria. And that criteria is we determined up here when our starting vertex index is. So we only want to copy into this list vertices up to the starting vertex index, and that's what this is doing. So then here we'll put a comment, do the subdivide, and then after do the subdivide, how about we copy mesh data as is after the selected face. And then the way that'll work is that'll be another for loop, int I, except this time I is going to be the starting vertex index. Why do I keep forgetting the I? It's going to be the starting vertex index, but it's going to be, we have to go, the starting vertex index starts us at our selected triangle. Well, how many vertices make up a triangle? 3. So we're going to want to skip past 3. So we're going to start at starting index plus 3. That'll skip us over the triangle that we were selected. And while I is less than vertices dot length, essentially we're going to do a new vertices dot add vertices I. So hopefully that makes sense. So up here we have the copy mesh before. We're going to go from 0, which is, it's a 0-based system. We're going to go from the start of the mesh data up to the selected face that we have selected. Then we're going to do the subdivide. We haven't done anything there yet. But then after the subdivide, now we want to copy the rest of that current mesh data that's already in there. So we're going to start the loop at the starting vertex index, which is where we're at. The starting vertex index is the selected triangle. Triangles are 3 vertices. So in order to go past that triangle we have selected, we have to start at starting vertex index plus 3, and we continue the copy as long as we haven't reached the end of the vertices array up here. And then we're just adding it to there. So this will handle the before that's selected. This will handle the after subdivide. Well, it'd be nice if we were done, except now we have to do the subdivide. All right, so let's go back to our diagram. And if we go back to our diagram, let's go back to the original one. So the first thing we want to do is we want to store where A is, where B is, and where C is, right? Because that's the initial triangle we have selected. So what we want to do is, why don't we go ahead and just say, let's just say A equals, okay, well, what is A? Well, we've been talking about that. A is vertices at the index of starting vertex index, right? Well, where's B? Well, B is at the startex vertex index plus 1. Where's C? That's at the starting vertex index plus 2. So now we have the A, B, and C. So let's go back to our diagram. Let's go back to the next diagram. So now we want to compute this AB, this BC, and this CA, which are the halfway points between what they're called, right? Well, so how do we compute that? Well, let's go back to our code. First thing to realize, again, to restate, AB is halfway between A and B. BC is halfway between B and C. and CA is halfway between C and A. I mean, my diagram may not be exact there, but that's what it's supposed to be. At least that's the diagram, what it's supposed to be. So if we go back to writer, why don't we go ahead and, much like we did with the A, B, and C here, let's just create some data to represent that. So we want to create some data structures for that. So why don't we just do that? Some variables here. So vector 3, why don't we have A, B? Let's just define these first, and then we'll start substituting them in what they actually are. So we want those halfway points. We want what AB is, what BC is, and what CA is. So if we go back to our diagram and we look, let's just say AB. Well, if it's just the way this triangle's set up, it's basically give me halfway the X between A and B. And for between A and B, that's true on this particular diagram. But remember, this triangle can be anywhere in space. So what we want is we want half of everything between A and B. So the way you would do that is, let's go back to writer, is you would want a new vector here, new vector 3, equals new vector 3. Well, what's this going to be? Well, it's going to be A dot X plus B dot X for the X coordinate, and we're going to divide that by 2, right? Because that's going to give us the halfway for that. But we have to do that for all of the components here. So A dot Y plus B dot Y, not byte, B dot Y, divided by 2, and then A dot Z plus B dot Z divided by 2. So let's get rid of this. So you can see it's better. So this A to B is going to give us halfway between A and B for all 3 of the coordinates. Well, you can probably guess what B to C is going to be and what C to A is going to be. So let's just copy this. Oops. Let's put an equals there first. Okay. All right. But this BC, again, we're going from B to C. Well, same thing, except this would be from B to C, from B to C, from B to C. And I'm pretty sure you can guess what this C to A is going to do. So C to A, C to A, C to A. All right. So now with these variables here, we have these 3 points. Now what we want to do is we have all our points. We've got A, A, B, 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 C, 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 A. We have all these points. Now we want to start representing these 4 triangles now. So we're going to have triangle 1, triangle 2, triangle 3, and then triangle 4 will be that middle one. So how do we do that? Well, it really is just looking at the diagram. So like, what's the first triangle? Let's do this upper one. Now we have to remember, going back way back to the cube video, if we remember the culling that we talked about and the winding of the vertices in order to know what front and back is, we have to make sure that these are wound in clockwise order. So for the first triangle, we want A, A, B, C, A, right? That gives us this triangle here, A, A, B, C, A. So if we go back to our to writer, and we want to represent that as a data structure of some sort. But this is going to be 3 vectors. So what we'll do is we'll just represent them as an array. So we're just going to call this T1 for triangle 1. And what this is going to equal, again, if we remember, it's going to be A, A, B, C, A. So the first triangle is A, B, C, A. Let's go back to our diagram. A, B, C, A. That's our first triangle, this triangle up here. Now we want to do this triangle. A, B, BC. AB, B, BC. That gives us this triangle. AB, B, BC. So, in fact, let's just do all four. Let's list all four anyway. Okay. So triangle 2 is going to be, starts at AB, B, BC. So triangle 2, AB, B, BC. AB, B, BC. Okay, we got this triangle. Now we want this bottom triangle. What is this? Well, this bottom triangle is CA, BC, C. CA, BC, C. So we go back to Writer, and it's going to be CA, and then BC, and then C. And then for our final triangle, that's this green one in the middle here. We want to represent that. So it's going to be, let's start here. As long as we go clockwise, it doesn't matter where we start necessarily. So we're going to do CA, AB, BC, right? That gives us that green triangle there. CA, AB, BC. Let's go back to Writer. So it's going to be CA, AB, BC. Okay. So now we have these four things here are all of our triangles that we need. So what do what do we do with these now? Well, we have the triangles. We just have to add these now to this new vertices list. And I'm going to do this in kind of an inefficient way because I think it's more important to show clarity on what's being described here than to find the most efficient method, because honestly, some of this is not very efficient. But then again, this whole video series I caveated with, this is just for demonstration purposes only. Like, don't do this stuff in production because you're going to find that performance is going to not be the greatest thing. So why don't we just do a for each? We'll do several for eaches actually, just to keep this real simple. And we'll do these are vector 3s. Again, our old friend, the vertex. In collection, well, what collection are we talking about here? Well, let's do T1. And what we want to do here is we want to new vertices, and we want to add. We're going to add the vertex for T1. Well, let's just do some copy paste here. Bam, bam, bam. Well, this one's now in triangle 2, triangle 3, triangle 4. Okay, and then after that's done, then this is that part that we wrote before where we're copying the rest of the mesh in, so that's already taken care of for us. So we're good there. And then we're going to generate the normals and all the rest of this. So this should take care of the subdividing. Now this isn't exactly complete yet because if you remember when we first set up our cube, we set up a static body and then we created that tri-mesh, which we just did in the last video, so that we know where we're clicking. Well, now we've changed the mesh. So now that shape index that's coming in, once we subdivide it, it's not going to be correct. Same thing with the wireframe and same thing with the normals. So we need to fix those pieces as well. So what we need to do, let's go back up to, let's do the draw wireframe first. So if we go to the draw wireframe, all right, what we need here, let's close this up again. We need this to be like we did with the selected face. See, right now it's always creating a new one. It's not looking to see where the old one is, and we don't want that. If we go up to the draw selected outline, see how we're grabbing this immediate geometry, and if it doesn't exist, we're creating one. Otherwise, either way, we're clearing it and starting over. We want something like that. So let's just steal this, because copy paste is a good thing. So we're in the draw wireframe. So what we want is we want something like that. So let's put that here. So we've got the immediate geometry, except it's not, this isn't the right name here. We want the wireframe immediate geometry name. And then inside here we want if immediate geometry equals null, then we want to create a new thing. And then we have to get rid of this here because we've already defined a variable called immediate geometry. Now we're trying to define a second one. So if we just get rid of this, we're not defining it, we're just assigning it. All right. And then the other thing we did, because if it's new, we want to add the child. So let's get rid of this commented piece out. The piece that's adding to the child, we'll copy that, we'll cut that, and we'll put that here. So essentially, this is going to read like the draw thing did. So basically, it's going to try to pull the immediate geometry out. If it doesn't find it, it's going to create a new one, and it's going to add this as a child of the cube mesh, and then it's going to do the rest of this. But one other thing we need here is we want it to start fresh. So if you remember, what you do is you issue this clear, and this clear basically erases everything that was currently in the immediate geometry. Again, going over what we did before, but it's worth restating. So like when you have a new immediate geometry and you clear, well, there's nothing to clear. That's okay, though. I mean, clearing nothing's fine. But if you do pull one out, which we will be doing when we redraw the wireframe, we definitely want to clear that out because we want it to redraw the wireframe. And the reason we have to redraw the wireframe is, remember, the old wireframe didn't have the new little triangles in it. So if we didn't draw the new wireframe, we would never see that there's actually new faces there. So that's why we have to redraw the wireframe. So this should be complete, I'm hoping. So let's go back down to our subdivide. And did I screw up here somewhere? Oh, I'm sorry. I didn't give an incrementer here. I saw a red line down here. I was wondering what that was. So on this as-is thing we built, I didn't give it a how to go through the array after that. So that's fixed now. Okay, so going back to what I was saying. So now we have to redraw the wireframe. So at the very bottom of this, like, let's draw the, we're setting the selected outline to nothing, remember? So right after this, why don't we just say draw wireframe. And that should redraw the new wireframe with the little triangles. So let's take a look at this. The normals still aren't going to be correct, but let's run the game and at least see if this is working for us, and then we can try to fix that little piece, which will be very similar to what we were doing, what we just did with that immediate geometry and checking if it's null. And we're basically going to redraw the normals. But let's see if this works first, because I already caught one error in Writer. Let's see if there's any more that I missed. All right, so let's select this triangle and let's hit the S. Something's not right there. As you can see, it did create new geometry, but it's doing something. It's like insetting that. So I'm wondering, let's take a look at what I did here. Maybe I did something. Oh, I must have done something wrong. All right, let's look at how we're doing these triangles again. Maybe I messed up somewhere. All right, A, B, A, B, A, B, B, C, B, C, B, C, C, A, C, A, C, A. All right, these look right to me. And then, is there any way to put these on the screen at the same time? I'm going to make it. Well, that's kind of small. All right. All right, let's see what we got here. So A, B, C, A, that's right. A, B, 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 C, that's right. C, A, B, C, C, that's right. And C, A, B, B, C. I think that's, let's go over this again. All right, triangle 3. C, A, B, C, C. C, A, B, C. Triangle 4. C, A, B, B, C. Yeah, that looks right to me. All right, so it's after that. So then I'm new verticing. I'm adding all the T1s. I'm adding all the T2s. Adding all the T3s. Adding all the T4s. And let me stare at this for a second. Maybe I'm doing something wrong here. Starting vertex plus 3. Vertices length, I++. New vertices add, vertices I. Where did I mess up? Let's go up here. All right. So, starting shape index times 3, that seems fine to me. Starting vertex, I++. That seems fine to me too. A, B, C, that seems right to me. So I'm wondering if I'm just missing something here. A, B, A, B, A, B. B, C, B, C, B, C. C, A, C, A, C. Oh, no, that's right. But that's an X. There's the problem. All right, that should be... In fact, all of these I screwed up. Z, Z, Z. All right, let's look at these closer. I was so busy by getting the ABs right, I didn't realize those were wrong. So AB with X, AB with Y, AB with Z, BC, BC with X, BC with Y, BC with Z, CA, CA with X, CA with Y, CA with Z. All right, I bet you this looks a lot nicer now. Let's run the game again. All right, let's get a little closer. We'll select this triangle, hit subdivide, bam! So you'll see, you notice that this is now split into 4 triangles. This triangle here, you got 1 triangle there, 2 triangle there, 3 triangle there, 4 triangle there. So it did subdivide. However, we won't be able to select these because it still has the old, see, I'm clicking around and it's doing really bizarre things, because it still has the old collision mesh on it. But it's subdividing now, so that's good. Okay, so let's go back to Writer. All right, and let's go to where would that be? Create. Well, actually, let's fix the normals first, because that should be the easier of the two, or at least similar to what we did before. All right. So it's the same thing where we need to make sure we're replacing the normal that we had before. So let's steal this again. Boink, doink, doink, doink. Draw face normals. Okay. So what we want to do is we want to create this immediate geometry, except it's not the wireframe name. What we want is the normal one. Okay. And then we want to say if immediate geometry equals, equals null. We want to create this new thing. We don't want to define another immediate geometry. We want to do this. We want to go to the bottom, get rid of that, steal the add child, put that in there. And then we want to make sure we clear. All right, so this should redraw everything. The face normals now should be redrawn. So we have to request that to be drawn. So let's go back to our subdivide. So after we draw the wireframe, let's call draw face normals. And now we should get the little lines. Doink. All right, so if I select that, hit subdivide, you notice now, in case you didn't before, but now there's little lines coming off of those new triangles that we made. See them? Okay, but we still can't, like I can't select, the selection's all messed up now. Sometimes it works, sometimes it doesn't. That's because the collision mesh is based around the old triangle system. So we need to fix that, which isn't as difficult as you would think. Well, let me rephrase that. There's a little bit different here we have to take into account. So let's go back up to our create and assign cube, because that's where we're assigning the, there we go. So we're in the create and assign cube mesh, and this is where we're assigning the, so this creates tri-mesh collision, and then we're doing the static body stuff. And in this case, we can assume that the child is the 0th child because there's nothing else in there. But we can't do that the second time through because, well, as we remove and keep re-adding, we have those two immediate geometries that are going to take over there. And it won't always be, we can't do the 0th for anything but the first call of this thing. So, I mean, we're going to we should probably refactor this so it takes into account that stuff. But I'm just going to leave this as is, and I'm going to simulate something very similar here. Let's just copy this as is for right now. Actually, and if you recall, we need to set up these if we're creating a new tri-mesh collision, this is going to create a new static body, and we're going to need to reassign these callbacks back. So let's just copy that. This isn't exactly correct down here, but it's mostly correct. So if we pasted this in, which is mostly correct. The thing is, we don't want to have multiple static bodies. So we want to actually remove the static body that existed already. Kind of like the immediate geometries we were doing. Remember, we were checking to see if that node existed. If it did, if it didn't, we were going to create a new one. Otherwise, we were going to use the old one. Well, in this case, we want to delete the old one if it exists, and then create a new one. So what we're going to do here is before we create the tri-mesh collision, let's just grab the static body. And the way we're going to do that is we're going to query the cube mesh instance, and we're going to get the node, and we're going to query on the cube static body name. And so what we're going to do is we're going to remove that child. Static body. And it's removed, but if you remember in Godot, in order to get rid of something, you have to queue it to be freed. So what we're going to do is we're going to queue free here. And then we're going to create a new tri-mesh collision. So let me walk through this again just to make sure that this makes sense. So we're going to have to do something here. So so we're getting the cube static body name. We're pulling out the static body that already exists on the old cube before we change the geometry. We're removing that as the child of the cube mesh instance. After that, if you remember in Godot, you have to call queueFree on a node to get rid of it. So after queueFree, in theory, at least in our minds here, that static body's gone. Then we're going to create a new tri-mesh collision. Now here's where we have to do something different. We can't do a get child 0 because we don't know at this point. In fact, it won't be the 0th child because we've already added. The first time we created the cube, we created the static body, which was the first item, and then we created the wireframe and the normals, the immediate geometries. So when we get rid of the static body when we're in here, we'll get rid of the static body. Well, all that means now is that, I forget which one we defined first, but let's just say it's the draw outline. The draw outline is now 0th. We can't do that. Well, we could try to do the last item, but let's not do that. Let's make this a little bit more robust. Honestly, this piece of code we're writing here, we should probably move to its own helper method and then have the original definition be this. But again, I'm trying to keep this so it makes sense versus is efficient. So let's just do this. We say found node equals, and we'll just set this to null. And then let's do a for each. And the variable itself, we're going to iterate through the nodes that are children of the cube mesh instance. So what we're going to do here is we're going to do a cube mesh instance dot, and we're going to do get children. Okay, so what do we want to do here? Well, we want to say if the node, if it's a static body, then what we want to do is we want to say found node equals true, and then we're going to break out of this for loop. No, not true. It equals the node. There we go. All right. So then what we're going to do here is then we're going to say if found node, if it's not equal to null, and it better not be, then what we're going to do is we're going to do all this stuff here. We don't need this, but we do need, so what we're going to do here, just so the naming convention works a bit easier, what we're going to say here is we're going to define a static body. We're going to call it cube static body, and it's going to equal a cast of the found node. Cube static body, cube static body, cube static body. All right, so I'm going to walk through this again because I realized this was kind of confusing. All right, so at the very top of this, I think we've covered pretty well how we redefine the geometry. We subdivided. Then we draw the selected outline, then we draw the wireframe, then we draw the face normals. We do them again, so it takes into account the new geometry. So now we have to get the static body that was currently assigned to the cube mesh instance, and we need to remove it. Now we want to create a new one of those tri-mesh collisions so it takes into account the new geometry. But we can't, just like we did before, just assume that the first child is the static body. That was awfully convenient, but in this case, we can't count on that. So what we do here is we're going to iterate through the children of the cube mesh instance, and when we find one that's the static body, we assign this to that and we break out. So now we know what the static body is. Most likely that we could go to the very last cube mesh instance child, and that would be the static body, but I think this is a little bit more proper, I guess we'll say. So we're not just assuming that it happens to be a certain place in the children list. So what we're saying here is that the found node is not equal to null. It better never equal null because we just did this, but it's always good to put a safety check in there. So if it's not null, what we're going to do is take that found node and we're going to make it, cast it into a static body, because we need it to be a static body so that we can do these connections down here. So then we're going to assign the name back to cube static body, and then these three events that we have to line back up because we're using, we reassign those. So now in theory, when we run this program, it should work and allow us to repeatedly subdivide all over the cube if we choose to. So let's see if I made any more mistakes. So if we run this, let's scoot just a little bit in. Let's grab this guy, subdivide. All right, let's grab this guy, subdivide. All right, let's grab this guy, subdivide. Okay, let's grab the one up here, subdivide. Let's grab this one here, subdivide. Okay. As you can see, the new geometry is taking form. So grab here, subdivide. Grab here, subdivide. Let's grab this one, subdivide. Let's grab this one. So, although I am having fun with this, as you can see, I mean, this obviously is, if you were creating some sort of modeling program, you would need to do more than just subdividing like we're doing. I mean, you might even have to, like if we were doing an extrude, you couldn't just create the new geometry like we did and be done with the subdivide. You'd have to see what it's connecting to, if anything, in the current mesh and do something with it. But, I mean, we're not doing anything where that's actually going to matter. So hopefully you see that this is, I think, pretty cool. And I also think that this fulfills the goals of what we were doing what I stated I was going to do in this video series. Because now we created, which was the cube, and modified. We also modified / created these by subdividing. We created and then modified. Well, modified and created at the same time. So I do believe this meets the criteria for me to end this video series. I don't think there's anything left to do here on this video series. I think I've accomplished everything I want. My channel is going to be active. I have lots of other things with Godot that I would like to pursue experimentation with. I will come back eventually to doing 3D stuff, but it won't be with this particular cube on the plane. I'll be doing other things. But I do think that this gives us I personally think, I mean, for me anyway, I'm going to take this code and it's going to be a project that I refer to so that when I want to know how to do something, months later when I revisit doing stuff with the SurfaceTool or Mesh Data Tool, I can just refer to this. And I'm hoping for the viewer, it's the same thing. I also want to state again, because I stated this at the beginning of the series, and I've stated it in several videos, this is not how, if somebody's moving a system into production or even just beyond playing around, shoving everything in one file like this is absolutely the wrong thing to do. It's beyond an anti-pattern. It's just a bad idea. However, for our learning purposes, scrolling through one file and just having to find a method, to me, makes more sense than having to have Godot up and find the node that I have a particular script on that does a particular thing. I realize in separation of responsibilities for proper coding in Godot, that's exactly what you would want to do. But I think from a learning point of view, I think that would be a very difficult thing to show. It's much easier, I think, to just scoot around this file. And also, a lot of what we're doing in this even in this one file is not the most efficient way to do some of this stuff. But I did not want to be efficient. My goal here was to demonstrate. Get rid of this. My goal was to demonstrate how these things work, and not to be the fastest, most elegant, or even proper way to structure these things. So I'm hoping that somebody watching this is going to maybe nod and go, geez, okay, I learned something, that's cool, but I know how I can do it better. And that's fantastic. I mean, that's a huge double thumbs up right there, because that's what you should be doing. This was only for learning purposes. So my channel is probably going to go, I'm not going to say quiet. Here's the dilemma that I'm in. So I've been waiting for Godot 4 to come out, I think like everybody else. And the reason for that is Godot 4 has some changes to some things. And I'm trying not to go too far down tying things to Godot 3 so that when I start doing some other work in Godot 4, eventually when Godot 4 comes out, it's going to be dated and it's not going to fit. I mean, a lot of stuff is transferring over, but the stuff that I'm looking into, some of it anyway, is, they're renaming some nodes and they're doing some other things. So I don't want to jump too far into that. For what it's worth knowing, and I might get into that a bit here, because as far as I can tell, they're not changing how this works. But the next thing I'm going to be looking at for myself is skeletons and bones inside Godot, and specifically how to encode, kind of like we did here, encode how to create the meshes, how to encode, how to, forward kinematic and ideally inverse kinematics things. I realize that they have a node called skeleton IK, but by the way, that skeleton IK doesn't work right. At least it doesn't work right reliably, which has been extremely frustrating, because I've been wanting to use that for a while, and I think I'm just going to end up writing my own inverse kinematic routine just so that I can have something I can count on working reliably and being predictable. So anyway, I do thank you for watching this video series, And I'm hoping that a lot of you will stick around for the next series, which like I said, I haven't 100% determined what it's going to be, but the next thing I'm looking to get into is skeleton and bone stuff, using C# to modify that. And there's a good chance, maybe a 70% chance, that's what the next video series is going to be on. So until then, I would like to thank you for sticking with the series. And I'm hoping that this was useful for you, because I know for me, just learning this stuff, it was extremely useful for me. So I hope that this was good for you, and I'm hoping to see you in the next video series. Take care.